Hi, I'm Mohamed Lifi, PhD student from the University of Burgos, Spain, and University of Chagdoukhali, Morocco. And I'm going to talk in this presentation about the international mobility strategy of the École nationale de sciences appliquées El Jadida in Morocco, the case study of students' exchange with Spain. One of the key factors to boost socioeconomic growth in many countries is the cooperation programs in the field of education. Mobility of people and ideas at different educational levels are the main characteristic of such programs. Cooperation programs used to focus mainly on providing continuing education and training for a young academic staff and also to get a new partners and research collaboration. In this presentation, we will present firstly the École nationale de sciences appliquées d'El Jadida Morocco and the promotion of students' mobility. Then, we will focus on the case study of students' exchange with Spain. And we will finish our presentation by giving some conclusions. The École nationale de sciences appliquées El Jadida Morocco is a public institution dedicated to the training of state engineers, continuing education, and scientific research. And the main building of the École nationale de sciences appliquées El Jadida is shown in the two photos in front of you. The training course at École nationale de sciences appliquées El Jadida Morocco is spread over 5 years of study. It is structured in two cycles, a cycle of two preparatory years of 2 years and an engineering cycle of 3 years, following the picture in front of you. Each year, the first 8 or 10 candidates of the first year of the engineering cycle, energy and electrical engineering, will leave for Europe for an internship of 1 to 3 months in summer, as a part of collaboration agreement with foreign universities. The academic coordination of these international internships is supported by the lectures of the Department of Sciences and Industrial Technologies. By 2014, the École nationale de sciences appliquées Jadida Morocco and the Escuela Politécnica Superior at the University of Burgos, Spain, started their academic collaboration. Every summer period, the Energy Engineering Research Group at the University of Burgos received 2 students coming from the École nationale de sciences appliquées Jadida for a short training period of 1 month. The Energy Engineering Research Group at the University of Burgos started its activity by 1997. Since then, 10 students from El Jadida have come to Burgos in the period of 2014 to 2019 to develop experimental training at the Laboratory of Energy Engineering shown in figure in front of you, dealing with heat transfer and energy storage devices. The energy topics covered by the Moroccan students along their training stays in Burgos are mainly related to heat transfer in industrial process and energy storage. We present here a short summary of the most relevant. The first one concerns the heat transfer in a jacketed vessel to control the temperature of a liquid stored in a tank. This method for temperature control presents several advantages. The first one, many fluids could be used for cooling or heating inside the jacketed coils. The second one, the temperature and speed of the liquids is easy to manage. And the third one, the jacket is cheaper in comparison with the storage tank itself. The figure in front of you shows the experimental prototype available at the laboratory in Burgos. The second experimental device served to study the energy performance of the air as a refrigerating fluid using combined convection and radiation heat transfer, as shown in figure in front of you. It includes a centrifugal fan with a vertical outlet duct at the top of which is mounted a heater, and also it includes an horizontal cylinder. The mounting arrangement for the cylinder is designed to minimize loss of heat by conduction to the wall of the duct, allowing the combined effects of convection and radiation to be measured. The third experimental device used by some of the Moroccan students is an experimental bench for energy storage by using phase change materials, PCM. The figure in front of you presents the experimental bench, which is composed mainly of thermal storage system and two heat reservoirs, hot and cold. The generator reservoir corresponds to the thermal energy producer, that is, the hot source. For example, a solar cell or a geothermal pump, whereas the consumer corresponds to the cold source, which is related to the final application of the system, the thermal energy consumer. The thermal energy storage system is the one that stores thermal energy during the charging phase and that releases it during the discharging phase. It is similar to a mixing chamber, where the two fluxes coming from the hot and the cold reservoirs are mixed inside it. The more important elements are the shell and caps, the baffles, and the tubes containing the PCM, all made of stainless steel. Last but not least, is the only stay in 2018 of one student of the third year of the engineering cycle, aimed to develop his final master thesis. This work was close to the frontier between professional training and research activity, which is also an objective for the École nationale des sciences appliquées Jadida, Morocco. This experience was developed at the research laboratory of the Energy Engineering Group in Burgos. In this work, new experimental data of density, speed of sound, and refractive index and other thermodynamic properties are reported. The measurements were made using an automatic densimeter and a refractometer, and also experimental excess enthalpies of the pure and binary systems formed by complex fluids at 313.15 Kelvin and at atmospheric pressure were measured using a quasi-isothermal flow calorimeter shown in figure in front of you. The open approach taken for the laboratory experiences of the students lead to the acquisition of valuable competencies. First, scientific and technical competencies. A relationship between energy science and engineering problems, application of energy balance and heat transfer techniques. Second, operational competencies. Use of measurement instruments, estimation of uncertainty of calculated results, planning of experiment to achieve an objective, and writing a technical reports based on data. Third, research competencies. Use of high precision research techniques, culture of rigorous method to assure quality of research, use of scientific literature and databases for comparison and validation of results. Finally, personal competencies. Working in a team in an international context of different culture and uses, facing up to open problems, self-organization of work, effective oral and writing communication. As a conclusion, this contribution presents a case study of the cooperation for education and research program developed between faculties of engineering at the University of Burgos, Spain, and at the University Shaib Dukali, El Jadida, Morocco. The international strategy led by the École nationale des sciences appliquées d'El Jadida is aimed at facilitating the professional integration of its students in a national or international job market. The field of study was energy engineering in correspondence with the energy and electrical engineering degree of the students. The experience demonstrates the improvement of scientific, technical, operational, research, and personal competencies of those students participating in the experience. Thank you for your attention.